Section 5.7 looks at solving trigonometric equations. In the Google form, you answered the questions to example number 1. And so you checked to see if pi over 6 was a solution to sine of theta is equal to 1/2, and yes, it is. The theta being 7 pi over 6 is not a solution, since sine of 7 pi over 6 happens to be negative 1/2, not positive 1/2. And another angle that satisfies this would be another angle where sine is positive. Sine is positive in quadrant 1 and quadrant 2. Therefore, an angle in quadrant number 2 that has the same reference angle, that reference angle of pi over 6, would satisfy this equation. And we've spent some time in earlier chapters solving problems like this. And however, we've always had a restriction when we've been talking about these problems. And the reason we've had this restriction is because we didn't really talk about how sine or cosine or even tangent, how they keep repeating over and over and over again. So we restricted everything we were looking at to one full rotation around the unit circle. However, we know that our graph keeps going on and on and on in either direction. Therefore, you're going to keep having values or outputs that are equal for a variety of different inputs. If we look at the graph of y is equal to sine of x, we will see that the value of 1/2, which is about right here, has an angle here, here, and then it repeats over here and here. And so when we want to find the solution to sine of theta is equal to 1/2, because of the fact that sine keeps repeating over and over and over again, there's going to be an infinite number of solutions. And that's why in previous chapters, whenever I've asked you to solve something such as sine of theta is equal to 1/2, I always told you that theta was on the interval from 0 to 2 pi. And so because of this having an infinite number of solutions, we have to figure out how to write them. And so the way that we write them is by adding this plus 2k pi, where always what you're going to have is the period of your function. So the period of a sine function and a cosine function are 2 pi and then multiplied by k. Or if we were dealing with a tangent function, we would have just k times pi in this place. And you state wherever k is any integer. So if k is 1, k is negative 1, k is 0. Once you substitute a value for k and solve, you're going to get another value of theta for which this equation is true. Okay, so let's look at example number 2. It says to solve the equation cosine of theta is equal to 1/2 for all values of theta. So first, think about what is the period of the cosine function. The first thing you want to do is find all of the values that make this true for one period. And we know that the period of a cosine function is 2 pi. So the period of cosine is 2 pi, and there are two angles on the interval from 0 to 2 pi, for which cosine of theta is equal to 1/2. And those two angles, the easiest way to think about them or to find them is to refer back to your unit circle. So if we look back at our unit circle here, we want cosine to be 1/2. So we want this value down here to be 1/2. Well, our x value is 1/2 when we are at pi over 3. And another place in which our x value is 1/2 is down here in quadrant number 4, since cosine is positive in quadrants 1 and quadrant 4. So this x value is 1/2 when we are at 5 pi over 3. So therefore, we can say the two angles are theta is equal to pi over 3 and theta is equal to 5 pi over 3. And it doesn't matter which interval we are on, whether it's the first interval of cosine or the second repetition of cosine, they're always going to be located at pi over 3 or 5 pi over 3 or something that's coterminal to either one of those angles. Therefore, we would state our final answer as theta is equal to pi over 3 plus 2k pi, or theta is equal to 5 pi over 3 plus 2k pi, where k is any integer. So thinking about the graph of our cosine function, we want it to be the value to be equal to 1/2. So we found this point here. We would say that that was pi over 3. And then we also found this point here. That x value is our 5 pi over 3. And by adding 2k pi, we're going to add 2 pi, or 1 full period, to this value. That will take us to this point here. And adding 2k pi to this would take us to here for when k is equal to 1. If k is 0, you're going to get the two values that come directly from the unit circle. And so because of that reason, also if we were to go in the negative direction, a negative k or negative 1 as our k would get us these two values. And that's how we can come up with all of the values that are possible for that value, theta. Example number 3 wants us to solve the equation 2 sine of theta plus the square root of 3 is equal to 0 if we are on the interval from 0 to 2 pi. Now notice, this one gave us an interval. The previous one had said for all values of theta. So make sure whenever it says all values of theta, that is when we are going to be adding that 2k pi. But for this example, because it says simply on the interval, we don't have to worry about giving all of the values. We only need to give any value that falls between 0 and 2 pi. So for this, we have 2 sine of theta plus the square root of 3 is equal to 0. We are going to subtract the square root of 3 on both sides. We want to get that sine of theta by itself. Therefore, 2 sine of theta is equal to negative square root of 3. And then if we divide both sides by 2, we get the sine of theta is equal to negative square root of 3 over 2. And so we want to find where is sine, or where is the y value, negative, and negative square root of 3 over 2. We've solved many of these using our unit circle. So remember, on our unit circle, sine is going to be negative in quadrant 3 and 4. And we want that side to be the sine side, or the y side to be the square root of 3 over 2. And so we're looking at the angle here at 4 pi over 3, and also the angle at 5 pi over 3. So we would say theta is equal to 4 pi over 3 or 5 pi over 3. And we don't have to say plus 2k pi because it gave us the interval on which we want to give our solutions. For example number 4, you first have to get that theta by itself by isolating cosine. So we subtract the square root of 2 from both sides, and then we divide by 2. And we come up with the cosine of theta is equal to negative square root of 2 over 2. We know that cosine is going to be negative in quadrants 2 and 3, since in quadrants 2 and 3 is where our x values are negative. And you should know by now that that's going to be your 45, 45, 90 triangle because its sides are the square root of 2 over 2. So we're looking at the angle 3 pi over 4 and our angle 5 pi over 4.